We've discussed earlier that the rules of chess are neither true nor false. They're just made up. But if you have made up rules, couldn't you just change the rules? Well, sure. So this is the original back row of chess. You'll notice that the queen goes in the same color as the queen. This is the white queen goes in the white square, the black queen goes in the black square. And you can see that the rooks go on the outside, etc. You could change the back row. Here's an example. And now you wouldn't say that this setup is right or that this setup is wrong. These two setups are just different. Neither is true and neither is false. Both are simply made up. And if you played chess here with this type of a back row, your strategies, your tactics, your openings, they would be different than if you played with this back row. But that's not to say that these openings and strategies would be wrong and these ones would be right. They would just be different. You could change it even in a different way. Here's a different randomized back row or different changed back row. And again, we wouldn't say that this back row is right or this one is wrong. It's just different. It's just different. And if this was your starting point for chess, you would just have different openings, different strategies, and different tactics. You could make more changes. We could make more changes. We could maybe make a rule that bishops can only move the way that rooks can, and rooks can now move like bishops. We could make a new rule. It'd just be a new game. It wouldn't be right or wrong. It'd just be different. You could make a rule that says a bishop can move like a bishop for one move, and then the next time it has to move like a knight, and after that it can move like a bishop again. And again, that wouldn't be wrong, and it wouldn't be right. It would just simply be different. It would give you a different game. It wouldn't give you a more correct or a more incorrect game. It would just be a different game. Let's see how that applies to our discussion of mathematical logic in our discussion of geometry. Let's take a look at Euclid's postulates. These were the starting rules of Euclidean geometry. Just as we have made-up rules for chess, Euclid started out with some made-up rules. Here are the 5 postulates. The first one, a straight line segment can be drawn joining any 2 points. So if you have 2 points, you can connect them with a straight line segment. A straight line, rule number 2, or postulate number 2, a straight line segment can be extended indefinitely in a straight line. Postulate 3, given any straight line segment, a circle can be drawn having the segment as a radius and one endpoint as center. 4, all right angles are congruent. Now things are going to get a little weird. They're going to get a little strange. Rule number 5. If 2 lines are drawn which intersect a third in such a way that the sum of the inner angles on one side is less than 2 right angles, then the 2 lines inevitably must intersect each other on that side if extended far enough. Wow, that last postulate is not really as elegant as the first 4. Euclid, as it mentions over here on Wolfram Math World, he just used the first 4 for the first 28 propositions in the elements. But he eventually had to use the 5th. And after Euclid, so many people tried to somehow prove the 5th postulate based on the first 4. They wanted to turn this postulate from a postulate into a theorem. In other words, they wanted to use these 4 and somehow, based on these 4, prove this, and they couldn't do it. Well, as it turned out, somebody started asking a different question. Some mathematicians started asking, what if we made this postulate simply not true? Well, you have a couple of great mathematicians, Bolyai and Lobachevsky, did just that. They found that you could just change this postulate and you would get a different geometry. It wouldn't be right. It wouldn't be wrong. It would be, just as all geometry is made up, it would be a different made up geometry. Now here's where things get a little bit more interesting. One of the greatest mathematicians of all time was Gauss. He actually discovered the same thing, that you could change this postulate. He figured this out and he hid it because he thought that this would just be a chaotic problem that he would just cause havoc in the world. So even though he'd figured this out, he hid it. He didn't like this idea of a new alternative geometry. Later on, mathematicians would change other postulates. Some would change the second postulate or the fourth, and they would come up with new geometries. So just as by changing a little bit of chess, you can make a new game, by changing some of the rules of geometry, you actually make a new geometry.